Hi everyone, so I think I'm audible and visible to all of you. So please confirm me guys once you are able to see me. Okay, so good afternoon everyone. I think I'm audible and visible to all of you. Yeah, good afternoon Satish, Durgesh, Vijay, Manas, everyone, good afternoon. Yeah, Akash, Manas, hope you're feeling well today. Not that great, but yeah, better than before because since last couple of weeks, so we were having a lot of like a product deployment and all those things and bugs and so many things. So I was not able to get my sleep properly, and because of that. So apart from that, there is no issue at all. Okay, so better, guys, better than before. So let me share my screen and let's get started with the class. So today we are going to cover a very important and interesting topic, basically. So we are going to cover basically this one, a vector database, which is a backbone for any kind of application that you are going to build in today's world with respect to a agentic AI or maybe with respect to a RAG, whether it's a semantic search, whether it's a recommendation system or anything that you are going to build. This is going to be a backbone. Even when you will go to jobs, so here we are trying to show you a jobs based on the based on the resume that you are going to upload, based on the profile that you are going to upload. So this system is going to give you automated recommendation, and that too like in every 24 hours it is going to refresh. Apart from that, you can go over here and then you can try to even search for the job. For example, if I'm searching for maybe a machine learning, so I will be able to do a search and then quickly it is going to give me a response, and all those jobs has been populated in like a last 24 hours. Plus it is giving me even a recommendation based on my resume and whatever data and detail which is available inside my resume. So based on whatever it is able to build a memory, it is able to give me a recommendation. So all of these things are happening based on the vector DB that we have implemented in a backend. Now, so why we are talking about it, and again, as a part of your syllabus, this vector database is already available, because going forward, whatever application, because going forward, we have mostly a application based scenario. So where we will be building RAG based application, agentic AI based application, we will be building, or fine tuning based application, we will be building, we will be like building our own models. So everywhere, almost everywhere, I'm not saying like 100%, but yeah, in 90% of the cases or in most of the cases, you will end up dealing with these kind of a vector DB. So why and this this vector DB comes into a picture? We already have a lot of database in a SQL segment and in a NoSQL segment. If I'll talk about a SQL segment, so we have a MySQL, we have Snowflake, we have MS SQL, we have DB2, so many, a Postgres. So we have tons of DB over there. If I'll talk about a NoSQL segment, so again, we have a tons of databases like a MongoDB, Cassandra, HBase, Influx, or maybe like a Neo4j. So a lot of database we have even on a NoSQL side and even on a SQL side. But why we are talking about a vector database nowadays since last 2 years? Like most of the time we are talking about this vector databases, and we are not just talking about it, we are even trying to implement it. And even on Euron system, you will be able to see a very clear implementation. And I'll tell you, because I have personally designed this whole architecture, right? So it's not like I can't achieve the same thing without using a vector DB. I can do that, but it will be very, very slow. latency is going to be very, very high. And this is something that we have experienced. The reason was very simple, that we are trying to scrap almost a 15,000 to 20,000 job on a daily basis. We are trying to store those jobs somewhere, let's suppose, right? And then we have thousands of our students who is coming over here, and we have to basically see their resume, and based on the resume, we have to provide this entire recommendation, and that too in a real time, as precise as possible. Now, so we have to do a matching. So if I'll talk about a matching between these two data, so basically like what we are doing over here is that we have your resume. Let me write it down somewhere. Yeah. So we have your resume, let's suppose, and we are trying to extract a data from your resume, because it's just a text that we have inside your resume. So where you have mentioned the place where you are working as of now, or in a previous company where you have worked, or like tenure that you have mentioned, each and every whatever information that you are mentioning inside the resume. So obviously we are trying to get those data. We are trying to get those things, and technically it's a textual information that we are talking about, right? And just imagine thousands of resume. Every resume is unique in itself, right? So everyone is not going to work in the same company. Everyone will not be having a same kind of a skill set. Everyone will not be having a similar kind of experience level. A lot of variations, right? And everything is available into a textual format. And then on other side, we have basically a tons of job. Let's suppose we have a 20,000 job on a daily basis. It simply means that 6 lakh job as of now. And then in a upcoming month, so we have a plan to even bring lakhs and lakhs of jobs. So that's a system that we are trying to revamp. And this is where we are working as of now, that lakhs and lakhs of jobs, so that we should not leave even a single domain untouched, and we should not leave even a single job untouched, which is available not just on a job portal like a LinkedIn, Naukri or Indeed, but even on a career website, career portal of any companies, because every company will be having their own career portal and where they try to publish their jobs. So again, this is something that we have. Now, between these two, we have to do a mapping or matching, right? In a real time. So whenever you click, so we have to populate a result over here, and that too with the relevancy, we have to populate a result over there. Now, this kind of a search or this kind of a matching is not possible if I'm going to use a conventional database. For example, if I'm going to use a Postgres, obviously I can do a mapping. I'm not saying that I can't do a matching. There is other hundreds of ways which I can tell you by which I will be able to do the matching. Even in a MongoDB, I will be able to do a matching. Even with a Cassandra, I can do the same thing, right? Even with the HBase, I can do the same thing. So it's not like solution is not available, but what matters over here is a latency. So in a very first place, when we have built this one without using a vector DB, our latency was very high. So even to populate this entire result, system was taking around 7 to 8 minutes of time. Now it takes just 4 to 5 seconds of time, right? Just 4 to 5 seconds of time. And we are revamping it in such a way. And again, so another solution is a hardware based solution. So where I can try to spin more number of servers, more number of machine. So I can try to provide more number of compute so that my compute will be faster. But again, we are affordable, right? We are selling a subscription in $299. So we can't afford that many number of machines at a time, because every machine that we are going to add in our server, it is going to cost us a bomb of money, right? So we have to build an optimized solution, plus we have to build a user-friendly solution. And this is where we have done the integration of a vector database. And similar kind of a demo, I'm going to show you in my today's class, that how logically this vector database is going to work. So vector database is just a storage unit, you can say, just a storage unit, right? It's not doing anything. So we are trying to generate our embeddings with the help of some of the embedding LLMs, which is available in a market. I'm going to show you. Even on Euri, we have released those embeddings model. If you have not seen that, I'm going to show you that part. So we are trying to generate the embeddings. And I believe by now, by this time, we all understand that what is the meaning of embeddings. We have done that, right? We have seen a theoretical example. We have even seen a practical example. So embedding is nothing but converting some of the data, some of the textual information into a vector space by representing a numbers, right? In some of the dimension, maybe 512, maybe 1000 or whatever it is, right? So this is a simple layman meaning of a embeddings, right guys? Everyone? Yeah? I think we miss mastering a prompt engineering. Don't worry, I'll show you. Prompt engineering is like very, very easy. I'll show you I'll give you a list of thousands of prompts for a different task. We are using it on a daily basis. Yeah. So I believe we all understand embedding, a core concept behind a embedding. So embedding is nothing new for us, right? We have also done that while we were trying to create our own model from the very scratch. So every time we were trying to convert our embeddings into our data into a embeddings or into a vector space or into its numerical represents, right? Sir, you promised same thing on Euron since last 2 years. Nothing has been updated. So I have taken exit from Euron. Euron chapter is closed, at least for me. So I'm not a person who will be able to answer. It's been more than 1 year of time. So please don't raise a question over here. This is not a correct place to raise the question. Yeah. And whatever, as per like a promise part, whatever I have promised till I was available as a part of Euron, as a part of management, I have done every possible things, including a teaching. And again, I'm doing the same thing. Very simple. Yeah. So please don't come over here and try to raise those questions. I believe we have enough number of platform out there, so where you can go and raise it. But yeah, please try to learn something over here. I was teaching even before, since last 8 years, and even now I'm teaching. Whether it's an old concept or new concept, that's completely fine. Yeah. And not just teaching, even building a system. The latest one, right? The latest one which is required in today's environment, not the old one. Okay, so basically we understand a core fundamentals behind embeddings and we all are aware about it. And this is something that we are using even over here in this particular place. And this is something which I'm going to show you and I'm going to teach you even in my today's class, that how I will be able to use one of the vector database, how I can try to use one of the LLM models by which I will be able to convert my data into its numerical space or into its vector space. I'll try to convert it and then finally I'll try to store it, and then how I will be able to do a search, and then what will be the latency. So each and everything we are going to discuss over here. So are we ready, guys? Everyone? Yep, everyone? So please say yes, no, whatever you want inside your chat box. I'm able to see all your question or responses. Fine. Okay. So here, if you will go into Euri as of now, and if you'll go into API, so just 2 days back, so we have released a new model over here. So these models are basically for a chat completion, right? Or even for a real-time search, we have already released the model. Now this models is being used for a chat completion at the end of the day. I selected the role as a director, so the tool is taking a director role in all the fields as well. Yeah, so basically it's a vector-based search. So obviously it is going to give you a response in that way. So if it is giving you a wrong response, so yeah, please ping me in a chat with the snapshot. So maybe I'll be able to rectify it. We are still trying to make the system better and better day by day. So these are basically a generation-based model or chat completion-based model. Now recently we have released a chat GPT-based embedding models. I think 3 or 4 days this week itself we have released that part. And here now you will be able to see a text embedding 3 small. So basically it's coming from a GPT, chat GPT basically, or OpenAI. It's coming from OpenAI basically. So this is a embedding based model, and very soon, so we are facing a little bit of issue in terms of hosting this model. So soon this will be even available. Amazon Titan embedded text V2. Even this will be available so that you will be having a multiple option just for embedding. Likewise, so we are going to even release a image based model. So where you will be able to generate images just like a chat GPT. So we are even building those things, and soon it will be available. So today we are going to use this particular model from Euri itself. So we are going to hit Euri APIs and what this model is going to do at the end of the day. So flow wise, if I'll talk about, so flow wise, so basically I'm going to pass a text in a very first place. Now text will go into my embeddings, LLMs. For example, this one, it will go over there. It is going to return me a vector space. Basically, vector space is nothing but a numerical representation of this text with the help of this model, which I'm trying to use. So today I'm using this, in tomorrow maybe I will be using this. Maybe you can try to download some of the Hugging Face models. There are a lot of embedding model which is available even on Hugging Face. You can try to download that and you can try to even do the same thing. But yeah, the vector space, it will be different. Length of the vector is going to be different. So this is going to produce, for every sentence, it is going to produce a length of vector is equal to 1536. So again, context length is going to be a very, very big, so that it will be able to understand even big sentences at the end of the day, or like a long text format, it will be able to understand and it will be able to help you out in terms of a search in a better way. So first we'll take input as a text, convert it into a embeddings. It is going to give me a vector, which is a numerical representation. Then I will try to store this one into a vector database. Vector database, I'm going to store it. And then maybe I can try to search some of the text. Like I can say that, oh, tell me my name. So, or my name is Anshu Kumar. So whenever I'm going to search, so basically it will go back to a vector DB. It will try to do a matching over here based on the cosine similarity, or based on maybe some of the distances, maybe Manhattan distances, maybe like Euclidean distances. Depends what I'm going to configure, because everything is configurable over here. And then finally I will be able to get a result over here, that whatever text that you are searching for, so matching to this text, this is the data which is available inside my databases, right? So this database is just been used for the storage purposes. You will not be able to store something over here unless and until you are not going to convert it into a vector space. And to convert it into a vector space, you need some of the embedding models. A bigger is better. Always a bigger is always better, so that it will be able to understand a long context at the end of the day. And these are basically a pre-trained model. Even I can go ahead and I can try to train my own model. If you remember, so in a class itself, we have trained a word2vec, right? Word2vec we have used in a beginning of the class, this class itself, and with the help of word2vec and word2vec we have trained on our small data set, and then we were able to generate the embeddings out of it, right? So here I'm not going to create my model from the scratch. I will be taking the help of existing model which is available. This is what we do even in real time, and I will be generating a vector space. So this is the entire funnel we are going to cover in today's class. Is it making sense to all of us, guys? Yes. What is the meaning of this small? Small means, like I said, so this is the length of the vector for every sentence that you are going to put. It is going to create. There are some models so where like this length is more than even 3000 or even a 4000. Yeah, fine guys, everyone. Okay. So let's get started one by one, step by step manner. So let's do a coding, and while I'll be doing a coding, so I'll keep on like pinging the code inside your chat box so that you all can do it along with me. So let me open up my VS Code over here. Create a new folder, D drive code and vector CTOR DB demo. Just try to create a folder as of now and leave it. And like I said, so I will be using this model. Plus today I'm going to touch upon this ChromaDB. So this is the database which I'm going to cover in my today's class. Now, so if I'll talk about a ChromaDB, right? If I'll talk about a ChromaDB, so here on its official website, you will be able to find out that Chroma is an open source AI application database, batteries included. So basically it's an open source DB which is available to all of us, and we can try to, right? So we can try to host all of this DB in our own environment. Maybe we can try to Dockerize it. Maybe we can try to even host it on some of the cloud environment. So everything and anything is possible with respect to this ChromaDB. Again, so FASI comes with the same thing. So FASI is, I believe, fourth one. So Facebook AI semantic search. So I think name is incorrect. It should be SS, semantic search, FAISS, not IS. And then Pinecone and Baviet. So if you are going to go and search for Pinecone basically, so Pinecone and Baviet is nothing but, so here, like they have already like a, if I'll talk about a Pinecone, so they have already given you the hosted platform. So you can just go over there, try to add your card, and then you can, I think they are providing some free version as well. I'll try to check, right? But yeah, so you will be able to use a Pinecone, and then the way you are trying to store something into a vector ChromaDB, so in the similar manner, you will be able to store something into a Pinecone, and same goes for this Baviet as well, right? So they are going to charge you, and they are going to charge you like based on the consumptions. They are even giving you a free trial over here, as you can see. And even this one is giving you a starter plan, which is completely free. And they are giving you a complete serverless architecture. Serverless means one big server where you can go and you can try to hit it, just like a MongoDB, right? You can just go and try to store the data. If you're looking for a dedicated server, so maybe they have an enterprise plan as well, so where you will be able to get your dedicated server and everything. But yeah, everyone is giving you a free version, so that we'll be able to try and we'll be able to use all of these things. Otherwise, I can try to even create my own server on my EC2 instances, or maybe on a Google Cloud platform or Azure Cloud platform, or in any other cloud platform. I can try to host it. As simple as that. The way we try to do an installation of MySQL in my local, and similarly, I can do the same thing on a cloud. Similarly, these databases will go. So we can try to store it anywhere we want. How embedding models different from embedding like word to vector or OHE? So basically how it is different. If I'll talk about OHE, right? One hot encoding. So first of all, if you remember one hot encoding, so basically it is trying to convert all the data into 101010 with the length that we are going to define, or with the unique number of keyword which is available over there. So one hot encoding will not be able to understand a semantic and syntactic between the data set at all. I believe I have already done a lot of discussion on top of that. If I'll talk about a word to vec, obviously it's a neural network based architecture, but with the single dense layer. So it will be able to do a learning, it will do a weight update and training, and it will be able to produce a vector that I am looking for. But again, it will not be able to understand before and after. Now, this kind of LLM that we are going to use, so it will be able to eliminate all the drawback that we have inside word to vector. I don't think that we should even do a comparison with the OHE, one hot encoding over here. But yeah, maybe I can do a little bit of comparison with respect to word to vector. Even word to vector is a neural network based architecture. And this one is also a neural network based architecture, but it's a transformer based architecture that we are talking about, right? And I believe we all know what transformer does in terms of learning a relationship between a data set. Fine, making sense? One hot encoding will have the sparse data. Now that is one of the scenario. Obviously it will be having a sparse data. Other models will be having also a sparse data. That's completely fine. That's not like a concern at all. But again, in terms of like a genuine comparison, right? So you should always do a comparison between mango to mango, not between a mango to apple. So doing comparison between OHE and these kind of embedding models is basically a mango to apple comparison. But yeah, so word to vector, and then if I'm talking about this transformer based LLM models comparison, then obviously it's a mango to mango comparison, a better mango or like a best mango kind of a comparison that we are talking about over here. Okay, so first of all, we'll try to use a ChromaDB. So we are going to do a setup of a ChromaDB in my local, and then at the time of deployment, so whenever I'm going to talk about a deployment, so maybe I can try to even teach you that, okay, so let's try to do a self-hosting. Otherwise, even you can try to go over here and they are giving you some like a pricing, and then you can try to even like avail this one, right? Even from here, so you will be able to avail this one. So first, let's go ahead with the local, and then we'll try to move ahead with the platform based. It's just a connectivity that you have to change. Apart from that, you don't have to change anything. Okay, so here, first, let's get started with this one. So code example wise. So here embedding generation. So you will be able to find out a code till this point. Length embedding. This is for my Titan. Okay. So just we have to copy this particular code so far, and then I'll try to show you something. So new file, testing.ipynb. So here code, and Python environment wise. So I can use any environment. Okay. So this is basically a code which is already available even inside a Euri. Right, I have shown you the place, so where it is available. So code example and then embedding generation till this point. So this is a code for my text embedding 3 small model, which is a GPT based model, and this is basically a sample code. We are just changing like a model name over here, right? And then a dimension. So dimension wise, this one is better. So this one is 1536 and this one is just 512 dimension. So this is going to give you like a long vector, by the way. So here I'm going to use this one. So just copy this one, this particular one over here. Now what this entire piece of the code is going to perform at the end of the day. Let's try to understand that part. So here I'm trying to hit my endpoint. My endpoint is what? So API Euron 1, API version 1, Euri alpha embedding. So basically I will be able to reach out to the Euri system or Euron system. So where we are hosting this model, you all will be able to reach out to that particular place. Now, once you will be able to reach out to this particular place, so it requires basically a authorization. So it requires basically a key. Unless and until key is not available, you will not be able to hit it. So you have to replace this static one and then you have to paste your own key. So your own key will be available over here, your API token. So just copy it from here, your own key, and then paste it in this particular place, right? Paste it in this particular place. And soon I'm going to release even the SDK. So as you will go to Euri, so you will be able to find out SDK for like a Euri client and even for a LangChain. So I have created the SDK. So I was not keeping well. So I think in 1 or 2 days, I'm going to even make it as a part of PyPy so that you don't have to do anything. Just like you are using these models, right? Just by doing the installation, pip install and Euri AI. So inside the same Euri AI, I'm going to make even this one available. I think in 1 or 2 days, I just have to sit for 2 hours and I have to push that particular library into my like a PyPy package so that it will become global and all of you will be able to use it just by passing your API key. But yeah, even now I can try to use it. But ultimately, I'm just going to create another layer on top of it. So as of now, what you can do is, so you can just try to copy your entire key over here, right? Content type. And then here I'm trying to give basically the food was delicious and service was excellent. So this is my input, which I'm trying to give. So once I'm going to give this particular input, the food was delicious and service was excellent, you can try to change the sentence. That's completely fine. What it will do is it is going to go to this place by using this password, by using this authorization, and then it is going to use this model text embedding 3 small, which is a GPT based model. And it is going to give me a response. It is going to give me a response saying that, okay, so this is your final data that you have. This is your final data that you have. So now you can try to use this particular data and then you can try to maybe see the embeddings. So you can even try to print the length of the embeddings. You will be able to even see a vector space or the real numeric value of this entire sentence, which this model is going to return. This is already a pre-trained model and it's a big one, right? So almost it has seen the entire world's data. This particular model, if I'll talk about by OpenAI, so you will be able to see basically embeddings and you will be able to even check the length, whatever you want, right? You will be able to observe it, each and everything. This is what this sample code is going to do. And I will be using the same to perform the exact similar kind of operation. So is it making sense to all of us, guys? Yeah, is it making sense? Yes. Okay, so console.log, I have just copy and pasted my React based code over here. So let me go to code example, embedding. This is my console log. Okay, so chat completion, embedding. Sorry, I have just by mistake node based. Sometimes even I feel confused that I am working in Node or I am working in Python, because, or maybe JavaScript and Python, because I have to switch over from here to there. Yeah. So this is basically a Python doing the same thing. So generate embeddings is the Pythonic function. So the food was delicious, the service was excellent. Just change with your API key. It is going to give you a response. Then you can try to check the embeddings. You will be able to even calculate the vector normalization. You will be even able to check the shape of the embeddings. Whatever you want, you can try to check it. So let me show you a demo and then let's go ahead with the full scale application building. So let me change this with my own authorization key. Control V, Control S. Okay. Execute. Okay, install. Fine, guys. I believe this piece of code is not a big deal for any one of us. Yes. So executed this entire function, and then now let's try to call this function over here. So let's call this function. And as you can see, it is showing you a first 5 value of the vector. This is the entire array. And as you can see, what is the shape? Shape is basically 1536, means the sentence which I'm trying to pass over here. The food was delicious and service was excellent. So it is trying to convert this entire sentence, and it is trying to represent this entire sentence in this dimension with 1536 number of a numerical parameter. So this is the dimension. So 1536 is a dimension in which it is trying to represent my entire data set. And happily, I'm able to generate an embeddings out of it. Yes. So are we able to generate the embeddings, guys? Yeah. So we have given like a show me the embedding starting from like a 0 to 5. If you are just going to remove this part, so it is going to give you the entire embedding. So this is what we have mentioned. Yeah. So now you have the entire embedding. In between, you will be able to find a dot, right? Because my Jupyter will not be able to show you all the data, all the information. Yeah. So hope all of us are able to get the output. It simply means that happily I'm able to convert my data. This particular sentence, right? This particular sentence, I'm able to convert it into a numerical representation, right? Into a numerical representation. Now, what I will be able to build out of it, right? What I will be able to build out of it. So obviously, I will be able to build a tons of things. A recommendation system wherever it is required. A search system. So the way people was trying to implement search before in any of the portal or in any of the website, and the way people are trying to implement a search now is very, very different. LLM has changed even that particular part a lot. The way we were building our recommendation system before and the way we are building a recommendation system now, again, LLM has changed that a lot. The way we were trying to do a semantic or syntactic search operation or semantic syntactic operations before and now, it has completely changed because now we have a luxury. Now we have a flexibility to represent anything into a very high dimension, store it, and then try to map it. Try to like find out the distance in between. And then based on that, try to give a best to my user. So this is the data. This is the data which I'm able to generate. Now what we can do is that we can try to store this data. Right? We can try to store this particular data along with this sentence inside some of my system. Now, what system in which I'm going to store this entire information? So I'm going to store those entire information into these vector databases, either in Chroma, either in Pinecone, either in Waviate, either in Facebook AI semantic search. Is it making sense why we are talking about a vector DB and what we are going to hold inside a vector DB? Yes, everyone? Is it making sense to all of us, like why we are even talking about a vector database and what we are going to store? So it doesn't matter what vector database I'm going to use. Yes. So in any database, I believe you must be aware about at least one of the databases, maybe one of the SQL databases, one of the NoSQL databases. Generally in NoSQL database like Cassandra or Mongo, so we try to store a document, right? Document means one of the like information is called as, or one of the JSON is called as basically a document, right? If I'll talk about a SQL kind of a system. So over there, we try to store data into a tabular format, a structured data. Yeah. So in a based on the column, so we can try to store the data set. Now here, what we are going to store. So here we are going to store basically this one, and this database has been designed in such a way that whenever I'm going to, right? So whenever I'm going to perform a search, means let's suppose if I'm trying to give this sentence just to perform a search, this particular sentence, or maybe I'm trying to read out the entire PDF, right? And then I'm trying to do a search operation over here. So what it will do, so it will convert this entire data set into its numerical representation, and then it will try to find out a distance between a data set that you are trying to pass for a search and the existing vector which is already available into my DB. And whichever is going to give me like a nearest result, it is going to give you that as a outcome. So we are storing the text, its embeddings at the numerical value. Exactly. This is what we are trying to store. And then when we are going to do a search, right? So DB, obviously a storage operation, it is going to do what storage? This is storage. When we are going to do a search, I'll show you one small demo also. And first one small demo, and then I'll try to write a lot of like a code over here. So how search is going to happen? So search is going to happen based on the distance check. For example, so let's suppose I'm going to perform a search. Let me close this. A lot of like a tabs are open in my system. Oh, all these things I have discussed in my previous class. CFAR, okay. Okay, so basically how this search is actually going to happen at the end of the day. So search is going to happen based on our distance calculation. So there are something called as cosine similarity that we try to find out. There is something called as Euclidean distance we try to find out. There is like a something called as IP. So based on that, we try to do all of this kind of a search. Let me show you one of the most popular one, and which ChromaDB does by default, and which is called as cosine similarities. How calculation happens. So let's suppose we have this vector, right? We have this vector, and then I'll try to call, let me parameterize this one. Let me do one thing. I'll just try to parameterize this. So here I'm going to change, so generate embeddings. So I'll pass my text data over here. I'm just changing the same code, guys. Text data, and here, so I'm going to give the input, text input, same data. So I'm going to give as an input over here, Control S, and then click generate embeddings, and then I'm going to pass my name is Sudhanshu Kumar. Now, so this is going to give you the embeddings. As simple as that. It is going to give you the embeddings. It is trying to return me the embeddings over here, a complete embeddings. Maybe I can try to hold it. So data 1 embeddings. Fine. I can go and even I can check what is holding inside the, I can go and I can check what is holding inside the data 1. So data 1 is nothing but it's a vector of 1536. So basically it's a vector space of this one, as simple as that. Now I can try to call the exact same thing, and I can try to make it as a data 2. And here Sudhanshu Kumar teaches takes class for tech. Okay, so now this is my data 2. So here is my data 2. Now these are two vectors. This is one of the vector, and this is the another vector which I have generated. Now I believe we all understand and we all know what is the Euclidean distance, right? So in terms of Euclidean distance, so let's suppose we have 2 points, right? We have 2 points. So obviously we have 2 vectors, let's suppose. So we have 2 points over here, and in a 2D dimension I'm trying to show you. So let's suppose we have x1, and then we have y1, and then we have like a x2, and we have y2. So what is our distance? So what is the Euclidean distance between these two? So Euclidean distance is nothing but, basically distance is nothing but root of x1 minus x2 square plus y1 minus y2 square, right? So this is going to be Euclidean distance, by the way. This is going to be Euclidean distance. Now I have 2-dimensional vector over here. This is the meaning of a vector representation. Now, so in this case, in case of data 1 and in case of a data 2, what is the dimension of this vector? 1536. So x1, y1, z1, or x1, x2, x3, x4, and so on, then y1, y2. in this way. We have 1, 5, 3, 6 here and 1, 5, 3, 6 here. Means that many number of dimensions we are trying to acquire. So again, I think if I'm going to ask you that try to find out a Euclidean distance between these two vectors, you will be able to do it, right? So x1 minus x2, y1 minus y2, z1 minus z2, a1 minus a2, whatever is the dimension, right? And eventually you will be able to find out the Euclidean distance. So whenever this is how Euclidean distance we can try to find out, and we can try to write our own function, or we can try to call any of the numpy inbuilt function, which is going to give me eventually a Euclidean distances. So it's a easy peasy kind of a task. Now, so by default, the ChromaDB which I am going to use, so basically that particular DB, again, there is an option of finding out a distance between two vectors based on like Euclidean distances. But by default, they are going to use a cosine similarity. Now, what is the meaning of by default, by the way, this cosine similarity? So cosine similarity is nothing but, again, on the same term, let's suppose we have two vectors, right, in a 2D space. So this is one of the vector, this is one of the vector. So cosine similarity always try to measure a theta over here, a cos theta over here. Simple. Less the theta, more closer the data set is. More the theta, less closer the data set is. As simple as that. So this is something which is going to be done by basically a cosine similarity. So based on that, it is going to find out basically a cosine distances, and then it is going to give you the result. This is how search is going to happen. I'm talking about a search, that when I'm trying to do a search, what it will do. So it will try to take your search embeddings. It will try to map it with all the other embeddings, which is already available into your DB. Whichever is going to give a less value of theta, it is eventually going to be your nearest search, means a more matching sentences. As simple as that, right? So it is going to basically find out the theta in between. Now, if I have to show you a code representation, a raw code representation between data 1 and data 2. So fine, let's try to import first of all numpy as num. And if you have any question, guys, please go ahead and ask. I'm looking at your chat. Yeah. So just try to import numpy, and here, so I'm just trying to show you how actually search happens, because till this point, like converting something into a vector, I'm able to show you, right? I'm able to convert it. Now, how actually search is going to happen, although data is available in my ChromaDB, right? So by default, what ChromaDB is going to do, then I'll be talking about even a Facebook AI semantic search. So what kind of a algorithm they are using, what kind of a calculation they are doing in a backend. Similarly, I will show you like what Pinecone is doing, what Baviet is doing, so that even those search part, a matching part, is not supposed to be a black box for any one of us. And again, I can create similar kind of a database on my own as well, right? That is practically possible. So it's not very tough to create such kind of a databases, which is going to perform similarly like a ChromaDB and Baviet and Pinecone. You can do it. Basically, you can launch your own startup. People are launching it. There are now hundreds of like a startup, so who is just trying to provide you a services for like vector storage, that just for vector storage. So, and almost everyone is doing the like similar kind of a things. So maybe you can try to like think about launching your own startup as well. Okay, so we have two data. So we have a data 1 and we have basically a data 2 over here. And I'll try to see that how it is going to perform a distance operation in between based on the cosine similarity. Now, the formula for this cosine similarity is basically a little bit complex. Numpy dot operation it is going to perform between a data 1 and data 2 divided by, this is the formula basically. So numpy dot normalize it data 1 and into numpy dot try to perform the lineage and then normalize it data 2. Now this is actually going to give you a cosine similarity. That's it. This is going to give you basically a cosine similarity result at the end of the day. As simple as that. So a dot product of like a 2 vector and then divided by, so this like a numpy lineage, so linear algebra function that we are trying to call with the normalization, and this is going to give me a cosine similarity. So what is the cosine similarity between two data set? It's a 0.55%. Now what is the cosine? So after finding out the cosine similarity, so this is basically a cosine similarity. Now, so system is going to give you a result based on the cosine distances. Cosine distance is nothing but 1 minus cosine similarity. So basically this is your evaluation criteria. So based on this distance, it is going to map. So for example, I have two data sets, right? So whenever it is going to give me a result, so for example, I'm going to create one more data set over here. Let me create one more data set. So data 3, I'm going to create. So data 1, data 2, and data 3, I'm going to create. Now here, people call me by my name, Sudhanshu Kumar. Okay, this is my data 3. So data 1 is there, data 2 is there, and data 3 is there. Fine, data 3 is there. All this 3 data set is there. And we have like a people call me by my name is Sudhanshu Kumar. Then Sudhanshu Kumar takes classes for tech. My name is Sudhanshu Kumar. Now, so what do you think, guys? Which two data sets should be closer? Data 1, 3, data 1 or 2? Sorry, have I made some mistake, Ram, in saying something? Yeah. So which one will be like a more closer? So Ram, I think he has commented on this a cosine similarity. So basically, see, cosine similarity always try to look into how close the angle of two vectors are. As simple as that. So it always looks for the closeness. By the way, I think you are having some different version. But I think Euri has given you my version of the answer, indicating that the vector are perfectly aligned and thus are very close at the angle increased to 180 degree. The cosine becomes minus 1, indicate that vector are pointed in a opposite direction, which means that they are far apart as possible. So the closer the angle is to 0 degree, the closer the vector are. Exactly. I think this is what I was trying to say, Ram. Maybe you have some confusion, but yeah, my version was same. Now here, because this is what cosine similarity does. So how close the angle between two vectors are, and based on that, it is going to give you the result. Now, most of you are saying that sentence 1 and 3 will be more closer, right? So most of the people are saying, except Sundar. Sundar is saying 1 and 2. So Sundar is trying to say that my name is Sudhanshu Kumar is more closer to Sudhanshu Kumar takes classes for tech as compared to my name is Sudhanshu Kumar. People call me by my name, Sudhanshu Kumar. Let's see mathematically. Even I don't know the actual answer, right? So how I will be able to check it? Let's do the math. Let's try to call the cosine similarity things, and let's try to do the math over here. So here I have checked data 1 and data 2, right? I have already checked. So now let's try to do it for data 1 and data 3. I'll just change the data. So data 3 and then 2 and then data 1 and data 3. And cosine similarity 2. I've just changed the value over here. So this is a cosine similarity. Now print it. It's 82, right? Now what is the cosine distances? How I will be able to find out the cosine distance? So cosine distance I will be able to find out by doing 1 minus, right? I think all of you are able to see the result anyhow. So cosine distance is 0.17. Yes. So distance between data 1 and data 2 is what? So distance between data 1 and data 2, what was the distance, by the way? So distance between data 1 and data 2, data 1, where is my data 1, data 2 distance? Yeah. So distance between, cosine distance between these two is 0.44, data 1 and data 2, right? And then distance between data 1 and data 3 is what? 0.17. Yeah, 0.17. So let's suppose if you have like inserted all the data 2 and data 3 into some databases, right? Now, what it is going to give you as an outcome? Can I say that it is going to give you, like, whenever you're trying to search for data 1, you're trying to match with data 1. So which data it is going to give you as a return? Can I say it is going to give you return as a data 3? Yes. Can I see it mathematically, guys? So this will be the return. When I'm going to search data 1, it is not going to return data 2 as a best search. It is going to return data 3 as a best search. Can I say that? And how it is happening, I think we know the answer. Akash is pinging his key as well. So Akash, it will be better if you are not going to share your key over here, because everyone is having their own key. They can go and copy paste. Otherwise, you will end up exhausting your limit, and we will not be able to help you out in that case. Yeah. So I believe we are able to understand that how search happens. Plus, we are able to understand that how we are trying to create basically our embeddings. Both part is clear, guys, to all of us. So again, I'm going to reiterate. Taking our text data, converting it into a embedding vector, done, right? And then search operation. Can I say that what happens in a backend is clear to us? How we do that for the huge data set? I mean, like I have shown you x1, x2, right? Similar way. So whether data dimension is 2 dimension or maybe 2000 dimension, this is the reason you are using computer, right? Otherwise, for 2-dimensional data, I don't even need like a Python code. I can do it like just by writing a mathematical function itself. I can do it easily. I can do it. Yeah. So can I say that this funnel is clear? So how we are trying to take a text input, how we are trying to convert it into its embedding vector. And when I say that I'm going to do a search, can I say that I will be able to do it, right? Now here, vector DB comes into a picture, and here my embeddings model come into a picture. Can I say that this is the place where, whether it's a Chroma, whether it's a Waveaid, whether it's a Pinecone, whether it's a FAISS, Facebook AI semantic search, all these things comes over here, right? In this particular place where I will store the final information, the information that we have generated. And this kind of a model, whether I'm using a Amazon Titan model, whether I'm using a GPT small case model, all these things, all these embedding models will come over here. So I think conceptually things are pretty much clear to all of us. Anyone who is having any doubt, please let me know, guys, if you have any kind of a doubt. Ram is saying, I'm just clarifying my doubts. Cosine -1 means higher similarity, which means higher angle towards. Cos 1 means high dimension, less angle towards 0 in terms of high dimension. Means high dimensionality, meaning high, okay, dissimilarity, less the angle towards 0 in terms of vector dB. Okay, yeah, Ram. So Maybe our both interpretation is different, but yes, a simple meaning is closer the angle. That's it. Wider the angle, more the distances. Closer the angle, less the distances. Okay, so this part is clear. Now let's start doing it with respect to a ChromaDB. So when to apply a cosine or when to apply a Euclidean, again, there is no hard and fast or like a straightforward answer for that. You can try to test it, which one is working in an optimized way based on the data that we are trying to store. You can try to choose cosine, you can try to choose Euclidean. And again, cosine and Euclidean is not the only way. So for example, Facebook AI Semantic Search DB, which is a part of your syllabus. So when I'm going to teach that part, I'm going to talk about a approximate nearest neighbor. So I believe like if you are coming from a machine learning class, so recently I talked about a k nearest neighbor over there, right? A k nearest neighbor algorithm over there. So where it try to create the cluster with the similar kind of a data. So the FASI database, like a FASI vector DB, Facebook AI Semantic Search database. So primarily it uses nearest neighbor, approximate nearest neighbor technique to find out the similarity. So everyone is going to, so KNN, right? So basically there is something called as approximate nearest neighbor. So K nearest neighbor means 5 nearest neighbor, 10 nearest neighbor. This is where K comes into picture, right? And there is a term called as approximate nearest neighbor. It almost works in the same way with a very little modification, right? So it's coming from the machine learning class, by the way. No, K nearest neighbor, classification algorithm, doctor, I'm talking about. My bad if I have said like clustering. So K-mean is basically clustering. K nearest neighbor is a classification. So technically it's using a classification, K nearest neighbor classification, to divide it into like a different kind of a classes. So approximate nearest neighbor basically try to use. So when I'll talk about FASI, I'll talk about that a little bit. But yes, technique is not going to be same in terms of doing a search operation. Okay, so now let's do one thing. There is another searching technique called as IP, inner product. So inner product, cosine similarity, Euclidean distance, approximate nearest neighbor. Based on that, like you will be able to do a search. Why we should use an approximate nearest neighbor? So that you can avoid calculating a distance between your input string or your input embeddings and the rest of the embeddings, right? So basically the time complexity for that one is going to be ON, but here, so it's going to be, I think, O square, a time complexity, because you are matching every time you are going to enter some text, every time you are going to enter some data, it is going to calculate a distance with everyone, right? Everyone. So how I can avoid that part? The answer is maybe I can try to build something so where I don't have to go and check a distance with everyone and then give me the output. So what is the difference between KNN and K-means? One is a classification algorithm which works with the labeled data supervised, and K-means is basically a clustering, so which works with the unsupervised where we don't have Y. Any particular reason? No, Sanjeev, there is no particular reason. Maybe tomorrow if you are going to create it, so maybe in our initial days, you will just go ahead and say that, okay, I'll be using cosine. And then you will give like other options or a parameter. This is what ChromaDB has done. Okay, let's move ahead. Now here, so I'm going to create a Python file, basically, CHROMA, ChromaDB demo.py file. Let me give you a demo, guys, for this ChromaDB. One by one. So where we are going to complete the entire funnel, and I will be taking a multiple sentences. I will not be taking just one single sentences. And then how I will be able to convert these multiple sentences separately into different like vector space and sorry, not different vector space, embeddings I will be able to create for different sentences. And then eventually I'll try to store it inside my ChromaDB. So to do that, right, to achieve this one, first of all, what you have to do is, so you have to do a pip install chroma. pip install CHROMA, Chroma. So just do this, guys, pip install Chroma. Yeah, so in my system, requirement is already satisfied. In your system, I don't think that it is. So here is a command, pip install Chroma. So this is the very first installation that you have to do, guys, every one of you. Now, once you are able to do this like a installation, right? So you have to keep up and running this ChromaDB inside your local server, inside your local system. You have to keep it up and running. This is approach number one. Approach number two is that I can try to use my just a RAM or my main memory over here without even instantiating a server over here. So both the approaches are completely fine. I'll try to go ahead with the approach number one. So I'll try to spin my server, Chroma server in my machine so that it can create a folder over here. It will be able to store all the data, because in approach number two, the problem is that by the time you will run the code, it will be able to understand everything. It will not store anything. And once you will try to exit from the code, everything will be gone. All the data will be gone. So I'll be using approach number one. So once I have done the installation of a Chroma, let's try to start the server. So to start the server, you can try to run the command CHROMA, Chroma, and then run --, just try to give a path where it will be able to store all the information. So whatever embeddings you are going to create, and in a later stage, you can try to even read it out. And even this is the exact same way by which you can try to containerize it, or maybe you can try to host it on any environment that you want. AWS, GCP, Azure, whatever it is. So here path, and path wise, I can try to give my current path. And here, so I'm saying that try to create one folder called as CHROMA, Chroma DB _ data. So create this folder and then spin it. So you will be able to see this symbol over here. Let me ping you this piece of the code. Yeah, so first it will install, then I have spinned, and see it's up and running. Listening to the local host 8000, and here you will be able to see a folder, right? Folder. So where it is trying to use a SQLite server. SQLite is again in-memory database, SQLite server. So where you will be able to see other files as well. So once you will start installing it, once you will start storing it. Making sense, guys? Are you able to spin your ChromaDB in local? Yes, everyone. Are you able to spin ChromaDB in your local? Get error. What is the error, by the way? Yep. Yes. Okay. Devkumar is saying yes. Aswini is saying get error. What is your error? So maybe you can resolve it, because this is the simple command, right? So install it and then leave it. Fine. Now here I'll start writing my code in this particular place. So first of all, I'll try to import my OS library. I'll try to import my request, request request. I will try to do like a from CHROMA DB import what? So HTTP client, so that I will be able to connect with my CLIENT client to connect with my ChromaDB. And here, so just to load something from my environment, so I'm going to call .env import import load.env over here, and then just call this load load.environment method over here. Now why I'm doing this load.environment? Because I'm going to create one file called as dot again start with .env environment file I'm going to create, and I'm going to keep my Euri API key over here. So I'm going to keep my Euri API key over here. So Euri, or maybe I can write in a capital EURI, Euri API underscore key. So inside this, I'm going to keep my Euri API key, guys, by the way. So wherever it is required, I will just try to read it from here itself. So let me go to my Euri, and yeah, so I can try to copy my token, and I'll simply keep it over here. So it's available inside this variable Euri API key inside dot environment. So here, so when I do load dot environment, so by default, whatever data, whatever variable is available inside this one, I can try to load it. And this is the standard approach, by the way, for saving any API key. Anything that you don't want to like share with anyone or don't want to like spread, so you can keep it all the API key in the same places. So this is the import that we have to do, and then go to dot environment file and then try to. Okay, doctor is saying working ChromaDB, great, fine. Okay, so here, right, everything will work. It's not like tough, believe me, at all, not tough, right? So here, what I can do is, so I can try to load first of all Euri API key, and how I can load it. So operating system dot get environment, and then so here just try to pass same variable name. So from environment, just try to fetch this one and assign it to this variable locally, assign it to this variable. So here I will be able to get my Euri API key. And I believe we all know why do we need a Euri API key. To generate the embeddings. I'm going to use the embedding models to generate the embeddings. I need Euri API key. So one is fine. I will be able to connect. The second one is a ChromaDB. So my ChromaDB is running, right? My ChromaDB is running where? On this particular localhost. Localhost means my system. My system is behaving as a server on 8000 port. So I have to establish a communication between ChromaDB and my Python code. Fine. So here I have to establish a communication the way you try to connect with any databases, right? Whether it's a MySQL, MongoDB, everywhere is the same story. So nothing new, I would say. So here I can try to call HTTP client, and then host is going to be the localhost, LOCAL-HOST, localhost, and then on which port my Chroma is running. So PORT port is basically 8000. Leave it up and running. So this is going to create a client for my Chroma. So this is going to create a client for my ChromaDB. I will be able to connect. Now, once I will be able to connect, so I have to create a collection, the way you try to create a collection in case of MongoDB or Cassandra, right? In the similar way, client client dot get underscore or underscore create create underscore collection collection. So here I'm going to create a collection, and sudh Euron data. So I'll try to store something about me basically, right? So I have just given a collection name, a document name over here, that okay, inside this collection. And similarly, I can try to create any number of collection. For example, when you work in a real time, right, you create a multiple databases. I believe when you have started learning some databases, so employee database you must have seen. So there will be a salary databases, there will be a bonuses databases, there will be a PF databases, there will be a name and basic information databases. Likewise, we are trying to create a different collection. So one of my collection name is Sudhanshu Euron data. Fine. So I'm going to keep my own data over here. And this I'm going to name it as a collection, CLCTION collection. Okay, now let me ping you this piece of a code altogether. So anywhere, if you're not able to understand, do let me know, guys. I'll try to explain you. But I believe till this point, things are pretty much clear, right? Everyone? Yes, everyone. Please say yes or no, something. Yes. Okay. Doctor is saying yes. Fine. Now let's move ahead. Now, the very first also is not able to run the ChromaDB. Just check the command and what is the error that you are receiving. So please, you can take a help from Euri, or even you can paste it here. some environment or Python version issue. So if you are facing any kind of a Python version issue, in that case, you can just go and create a new environment. I believe we all know how to create a new environment. Command is conda, C-O-N. Let me write a command and paste it to you. So here itself, conda create -n. Give your environment name. For example, Shyam is facing an issue. So maybe Shyam can create an environment by his own name. SAIYAM, Shyam, Python equal to 3.10, make it yes. Install all the yes, and then conda create-n and this one. So maybe you can try to use this command, create a new environment, activate that environment, and then install in that environment. It will work. With 3.10, it will work. Okay. Now moving ahead, we are able to create a client. We will be able to connect with the DB, by the way, right? I can even test it. So how I can test it? So maybe or I can try to even no module name ChromaDB, some environment I have to change, or I can for testing purpose. So pip install. Oh, it will not be able to get into the server. This is the different environment. This is an assignment grader which I'm using. And I'm running my ChromaDB into my different instance. But let's see. Yeah. So I can even try to test it. Maybe I can try to just call a print over here, print print, and then print my client, so that I will be able to check my collection. So leave it as it is. Try to open up new command prompt, and then Python and Python CHROMA file. Yeah. So as you can see, I'm able to see my client object. This is what I was trying to print, right? Client object. So once I'm able to print this client object, it simply means that I'm connected with my ChromaDB, right? I'm connected with my ChromaDB. If you are not able to see this one, then you will get some sort of an error. It simply means that you are not connected to the ChromaDB. As simple as that. So testing is done. Okay, it's fine. Now, what is the next step for me? Next step for me is that try to write a function so which will be able to convert my textual information or whatever information which I'm going to scrap from anywhere, right? Nowadays, I'm talking about a lot of like a projects in MCP, and in every project, if you'll go and check, I'm trying to scrap a data from somewhere. I'm trying to read out some PDF, right? So whatever data which I'm trying to bring over here, I have to convert those things into a embeddings. Now, this is where my Euri will come into picture. So code example, I'll simply go, and we have already given you a code over here. So I'll be using generate embeddings, same code, which is already available, right? And then maybe I can try to parameterize it that, okay, so this is going to take text underscore list. It is going to take an input, right? Not just like this one. And here, text list, it is going to take, and then authorization wise. So bearer, I can try to pass over here Euri API key. Euri API key I'm going to pass. Now it will be able to authorize, and rest looks fine to me. I don't think that I have to change anything over here. URL header payload is fine. Model name is fine. Okay, so here I can give maybe F formatted string. Okay, so content type is fine, and then bearer is fine. So this is the only changes I have to do over here. Then it is going to return me embeddings. Fine. It is trying to print something over here which I eventually don't want. So I can remove this entire things. I just need till embeddings. Fine. So give me all the embeddings, response, request, URL header, data, response.json. So whatever response I'm going to get, extract is JSON, take it data, and then show me as a embeddings. Okay, fine, great. So here, right, So here I will be able to see the embeddings, and I will be able to see a core response which I will receive from a models. I will be able to see both the things in this particular place. Making sense, guys? Till this point? Okay, I have not done the import of NumPy. So NumPy as NP. Okay, so this is my generate embedding function. So I have just taken the same function which is available inside the Euri. And I'm not doing much. I'm just trying to like parameterize it. So pass the text list and then Euri API key. Just try to pass it, and then it is going to give me a response. Out of response, I'm trying to just extract embeddings in the format which I'm looking for. As simple as that. Okay. So one by one, it is going to give me the responses, but it is going to give me a response for only one data. That's a problem, because for single text it has been designed. It has not been designed for the multiple text. But let's suppose I wanted to pass a lot of data over here, not just one text, maybe like a 10, 20, 100 number of like a lines I would like to pass, and I want to convert those things into a embeddings. So for that, please show dot environment file once. In dot environment, I'm not doing much. So basically it's just a variable, Euri API key. I'm keeping my Euri API key. That's it. So I'm just keeping my authentication, this one. Copy it from here and then keep it there. That's it. Okay, so this is basically the function that we have given to you. So that has been designed for only one, like a text information. Now I'm trying to send a multiple, let's suppose. So to do that, I have to make a changes a little bit over here. So I can try to write maybe a loop over here. So for item in response that it is giving me, so whatever response that we are getting from here, so just try to extract it into a JSON format. Eventually I'm doing it with data, and out of that extract all the data one by one, and then from this item try to extract embeddings embeddings. So this is going to give me the data one by one. So fine guys, this is what I have written, because my intention is not to pass only one text. My intention is to pass a lot of text, lot of line over here, right? Lot of document, and for every document it should give me the embeddings at the end of the day. So fine, it is going to give me embeddings, and then I'm going to return this embedding. Let's make it S just to remove the confusion. So it is going to give me embeddings. As simple as that. Okay. So now let's try to create a data, right? Document I'm going to create, and I'm going to create a lot of data over here. So the very first line is, my name is Sudhanshu Kumar. I used to teach like a tech. Sudhanshu Kumar, total year of experience as techie is 11, as a mentor is 7, as a entrepreneur, entrepreneur, entrepreneur. I don't know whether I'm writing correct spelling or not, but yeah, I'm bad with that. So entrepreneur is 6 here. Okay. Then maybe I can try to write something more about me. I love Sudhanshu Kumar love teaching core concept and architecture. Sudhanshu Kumar love building tech, which is his favorite, by the way. And then Anshu Kumar have started a company called Euron. We have Euri, resume AI, job system, AVNI, with lots of courses, projects in different mode. Okay, so I'm not able to think much about myself, so I'll just go and click on founder story. Let me copy and paste some data from here, my own data. Okay, so this is one. Here it's mentioned where I belongs from. Maybe I can try to copy, paste again, created a data. Created a data once again. Okay, so a lot of data we have created, I think. Now, so this is enough. So these are the data that I have created. I will be using this data. I think I don't have any kind of a mistake I have made. Okay. So this is the data that I have created. I will be using this data. I'll try to pass this data inside this generate embeddings. And then system is supposed to give me basically a embeddings of this particular data in a one by one manner. Making sense, guys, to all of us? Yeah. So maybe you can try to prepare your own data, or if you want, you can take my data as well. Yeah. So I'm just trying to pass it as a list over here. Sir, why we are taking quotation in each line? So here, as you can see, I have a list, right? So this will be considered as 1, then 2, then 3, then 4, separated by comma. So one sentence will be converted into one embedding of size 1536. This is what it means. So a multiple like a sentences in this way, I'll try to like convert into my embeddings, and then those embeddings I'll try to store it inside this collection. Can you share the updated embedding code? Okay, I have just done a small modification. So code was actually designed for only like one sentence. I have just like run the for loop on top of it, so that for like everyone it will try to like do the same. Okay, now so let's call it. Let's see it. First of all, embedding part. So here I'm going to call my generate embedding function. This function I'm trying to call. I'll try to pass my document over here. This data I'm going to pass, right? And then it is going to give me all embeddings. It is going to give me. This is what it is trying to return, all embeddings, right? But in a this particular fashion, it is going to return. And maybe I can try to print and see it, right? All embeddings. So let's run it now. Let me ping you this code. So step number 1 will be done in this way. So Python ChromaDB Py, run it now, and as you can see, it has converted. And now if I'll go and check my Euri, so I will be able to see some token consumption as well. It's at 7% now. 70,000. A lot of like a use I have like done today, right? 7% consumption now. Okay, so here I'm able to convert my entire data, right? Convert my entire data into an embeddings. As you can see, it's a very, 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 very huge data that I'm talking about, right? A huge data I'm talking about. So now I have to store those information. I have to store those data. So I have to store basically like a data, as well as I have to store its embeddings. Something like that I have to store into the ChromaDB. If we have a single quotation, what will be the difference? No differences actually. Single quotation, double quotation means it's a string. So it's not going to make any differences, by the way. Sir, what is the best format to store the table semantic information where we are building a text format? So basically, best format to store a table semantic information where we are building text to SQL bot. Okay, so basically you can use a vector. You can try to store it in a vector. Or else as per Euri suggestion, JSON. But again, JSON is not that like a search compatible. So I don't like think you will be able to get the best outcome. So now I'm able to convert all the data into its embeddings. We have to do a lot of processing over here. So the all embeddings is nothing but it's giving me everything out of this one. Now, so if I'm going to even show you this all embeddings, basically, so maybe embeddings of just a very first one, embeddings of 0th or embeddings of like a first, second, third, you will be able to print because yeah, so as you can see over here, so embeddings of 0th embedding it is giving you, right? All embedding means what is this all embeddings? So this all embedding is returning this one. This one is nothing but it's a lots of item. What is the number of item? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So I have 12 sentences. So I have basically 12 embeddings, which I will be able to generate each of length 1536. I can even try to check it over here that what is the length of this embedding or for any embedding. So what is the length of this embeddings? I can go and I can try to even check. Yeah, so it's 1536, right? It's 1536. That's the nature of my LLM model that I'm using, OpenAI model that I'm using. So that's the nature of it. As simple as that. Now I have to save this entire things into my ChromaDB. My ChromaDB, which is up and running, which is like, I'm trying to like run it locally, right? So I have to save all of this embedding and then in later stage, I will be able to, or I should be able to search it, right? I should be able to search it. So how I will be able to save each and everything. So for that, we have already created a collection. We have created a connection after that collection. So collection is nothing but in this collection, in this document, I'll try to store all the embeddings. So let's go ahead and let's try to start storing this entire embeddings that we have created into my ChromaDB. So here, what I can do is, so I can call a zip my document and then zip my all embeddings. So zip it and then try to enumerate it so that I will be able to get a ID, enumerate it. So zip means mapping. So one mapping with its respective embedding. I believe we all understand what zip does in Python. I think I have already used it many times, even in my previous class. In my Python class, obviously I use it. So zip is nothing but, let's suppose we have like two data. So one is basically 1, 2, 3, and 4. And then we have another data, A, B, C, D. It will do 1-to-1 mapping. So this is my, let's suppose, a document and this is my embeddings. So it will create this pair. Basically, this is what JIP is doing. And for every pair, so we are trying to generate enumeration, basically one ID, 1, 2, 3, 4, 5, 6, and so on. So this is what JIP and enumeration is going to do over here. Now, after JIPing and after doing the enumeration over here, so we can try to run for loop. So for, we can generate a variable called as IDX, which is coming from the enumeration. And then for every IDX, we have a document and its respective embeddings. So this I will get from the JIP, and this IDX anyhow I'm getting from the enumeration. As a whole, I will be able to get this response. Okay, now try to call collection. This one, this is string collection, and then collection dot add in a for loop, one by one, I'll start adding it. So add what, by the way? So basically, or IDX docs enumeration. Have I made any mistake, by the way? It's showing me syntactical error. Okay, so this one, I believe. I think I have missed in. So, okay. Collection dot add. So document doc EMBEDDINGS embeddings is nothing but embed that we are getting from the data. Then metadatas try to store. So metadata is nothing but, I'm going to store it SOURCE source. So here sud, this is optional, by the way, data. I'm just trying to attach a meta with this one, and IDs. So try to store IDs. So IDs basically in a formatted string. IDX. Okay. So this is the parameter for my ChromaDB. So I'm trying to store 4 things over here. So in a first iteration, first document means this one, and its embedding, which I'm getting from here, and just a meta information I'm trying to attach. If you want to attach anything else, you can attach it, and then ID. So ID, which I'm getting from the enumeration. So in this way, it will be able to store all the information in my ChromaDB. I can try to print once all these things will be done. So all data stored in ChromaDB. Right? All data is stored in ChromaDB. Now, let's run it once again. And parallel to me, even you guys can try to test it. This one. Let's run it. So Python ChromaDB. And as you can see, we have a SQLite over here. It is collection got unexpected keyword argument document. It's basically S, not. Yeah, this is the parameter for a Chroma. So Chroma understands documents. Okay, so now you must be able to see some changes over here, guys, right? All data is stored in DB. Yes, and just change this document to documents. Let me ping you this code once again. So now all of these data and its document means the data, raw data, its embedding, this and its ID is stored into a ChromaDB, and you will be able to see some newly created object inside your ChromaDB. Are you able to get it, guys? Yes, are you able to get it? Everyone, are you able to store the data, guys? Are you able to see some different object over here? Sivananda is saying yes. Sivananda, Akash saying yes. Okay. So now successfully I am able to complete 2 steps. 1, converting into the embeddings. 2, storing into a ChromaDB. Now it's time to do a cross verification that what kind of a data which has been stored inside the ChromaDB. What is its embedding which has been stored inside the ChromaDB, And then I will try to even go ahead with the search, basically search something into my ChromaDB just by writing a query. Just we like try to write a query into a SQL, right? So just we write star, select a star from EMP kind of a things. So we'll try to even query our ChromaDB, right? We'll write some search query, we'll try to pass some data, and then I'll see. So what is the result it is going to give it to me out of this one. So now let's go for the verification now. All done, everyone? Any question anyone is having, please go ahead and ask. So this is done. Now it's time for a verification. So verification wise, I'll use a same collection object that I have created. So this collection object, which is helping me out to connect to my collection, right? So this collection object I will be calling from a ChromaDB. So collection dot get. So this is a function coming from a Chroma itself, right? So collection dot get, and then get what? So basically it is going to give you like all the things. So here I'm going to write include include. This is basically like a command from ChromaDB, documents, documents. So here it is going to give you all the items. So print everything so that I will be able to cross check. Collection.get means I'm not hitting my local, I'm hitting my Chroma basically. And let's see whether I'm able to get a collection or not. So first do CLS. So this read I'm trying to perform from my Chroma, guys. So now, as you can see, all data is stored, right? Then it is trying to return me what? It is trying to return me IDs. I believe we were storing IDs over here. So we have given docs and then ID like a name. So in this format, it has a stored ID. So doc 0, doc 1, doc 2, doc 3, doc 4, whatever I have given. If I would have given Sudhanshu over here, Sudhanshu 1, 2, 3, 4, and so on, it would have stored. And then, so this is my ID. So total 0 to 11 means 12 document is been stored as of now inside this ChromaDB. Embedding, none, metadata, none. As of now, it is trying to show me, and I'm trying to fetch just a document. So document, my name is Dhanshu Kumar. I used to teach this. So all of these data set is already stored inside this one. So can I say that, guys, successfully I'm able to store each and everything? Yes. Now I can even say that include embeddings. It will try to even print embeddings. Last time I have done just include like a document. So it is showing you just a raw document that you have. Now, let's see. So can I say that this time it is printing even the embeddings? Yes, guys, all of these embeddings I'm able to see over here. So it simply means that I'm able to store IDs, I'm able to store basically embeddings, and I'm able to store even if I'm going to like include metadata, so it will try to include metadata. Like I think we all know what I have stored into metadata, right? My own custom string I have stored. So this is done basically. So everything is now available inside my DB. Now it's time to use a DB, right? It is a time to use this particular DB. So to use this particular DB, maybe I can leave this code as it is. I can try to create another file, search chroma.py. I'm going to write another file, guys. So search chroma.py, and here, so I just need these imports, right? And I have to create, obviously, this connection is required. So connection string, I'm going to copy and paste. Connection string. I don't have to do anything with the LLM model now. So I just need like I have to interact with my ChromaDB because data is already stored inside my ChromaDB. So I can go ahead and then I can try to start searching each and everything inside that one. So here, let's do something just with this simple code. So here collection, and let's do a search over here, that how I will be able to like get some sort of a data out of this ChromaDB. So till this point, is it fine to all of us? Every time you are creating the embeddings while executing the code, yeah, that's the reason. So I have created the new one. This is what is happening, right? So unnecessarily I was hitting my Euri API because it was executing the complete code. So let's do it here separately. And it was overriding the same document. Yeah, so let's try to test it over here. Maybe we can try to do some sort of a search in this particular place. We can try to pass some of our own custom query over here. And eventually I will be able to see some sort of a result in this particular place. So here I can write collection.query coming from Chroma, collection query. And here, when we are looking for a collection query, let's suppose I'm trying to send something for a query. So you have to pass basically a query embeddings. So you need LLM, by the way. Query underscore embeddings, query embeddings. So whatever query you are going to pass, you have to convert those things into a embeddings, and then you have to pass those things into this collection.query. So here, let's suppose, let me create a separate function for this one. So def SEARCH search CHROMA Chroma. Now it is going to take what? So it is going to take maybe like a query text. So whenever I'm going to call, and then it is going to okay, so embeddings request numpy fine using which model? Same model. Okay. So I'm going to use a Euri API, guys, because what I'm going to provide a data into a text format. So it will take some data as a text format over here. It will take my custom text, and if here I'm going to convert it with my Euri API key. Same changes which I have done before. So this looks fine. Finally, it is going to return my embeddings. Okay, that's great. And this is generate embeddings I have created. All looks good to me. So this is going to create a embeddings. So this is going to return me the embeddings. I'm going to use that embeddings over here. So whatever query text I'm going to pass, it is supposed to call generate embeddings, and then it is supposed to pass the query text. So technically I'm calling this function. I'll be calling this function over here. Now it is going to give me a embeddings. So here, query embed, it is going to return me embeddings. Now I can call collection.query, and query embeddings is equals to this one. So embedding I'm going to pass, and then I'll try to search, and I'll say that while giving me a result, include a document as well. Means not just give me the embeddings, but try to give me the English document. So include documents means give me a sentences as well. Okay, and this is something it is going to give me as a result, RESULT, result. Maybe I can write it down in a single line so that looks clean. Okay, so this is going to give me basically a result. including a document, it is going to give it to me based on the embeddings which I'm going to pass. Embedding I'm going to create based on the data which I'm going to pass when I'm going to call search chroma. Once it is going to give me a return, then maybe I can try to print this entire return. So simple, go ahead as of now, print the result over here. Okay, that looks amazing to me. Search chroma, and I'm going to call my name is Sudhanshu. So this is my input data. I'm trying to search, and I'm trying to search that which and all like documents are closer to me. And again, yeah, one more things which I can try to print over here. So I can try to print a k nearest, means top, like a top, give me top 2, give me top 3 matching one. So again, I can try to parameterize that part as well. So here there is a parameter inside this ChromaDB called as n_result, number of results. So give me basically maybe like a top 2 result only. I've just hard coded it. Now save. Pinged you this code. Test it now. CLS. Python search chroma. Let's see. Bearer Euri API key has failed. Name Euri API key is not defined. Okay, good. I have not done the import over here. Let me do the import. Load environment. Load this. Load environment. Load this API key. Now it will not give me same issue. Okay, looks great. Run again. Got unexpected keyword argument, query embeddings. Query embeddings. Query embeddings. QUEEMBEDDINGS. Okay. Spelling mistake. Bingo. So now we are able to even do a search, guys. So what was my like I have passed this one. My name is Danshu. I have passed this document, right? Now it is able to match and I'm looking for what? I'm looking for top 2 result. So it is matching more closely with document 0 and document 9, right? It is matching closely with document 0 and a document 9. So what was there inside the document? My name is Dhanshu Kumar. That was a document 0. And this was my document 9, by the way. So while many would have been daunted by lack of support and opportunity, Dhanshu was relentless in his pursuit of the knowledge. He knew that education has a power to change the life, and he was determinant. So yeah, it is able to match with 2 top document. And 2 top document is doc 0, doc 9. And I'm able to get the result. Can I say that now my entire loop is closed? Yeah, I'm able to perform even a search operation. So now I can try to pass any kind of a data that I want. So Sudhanshu has founded Euron. Give me top 3 result. Yeah, so top 3 result, doc 5, doc 10, doc 6. It's matching with that. You can even read out the data. So Sudhanshu Kumar has started a company called as Euron. I have written Sudhanshu has founded Euron. So started a company called as Euron. So this is the very first matching, right? This is the building the success of Euron. Sudhanshu is now leading Euron. Again, looks like it's a very close match, right? So yeah. We are able to do the embeddings. We are able to store it into the databases. We are even able to do a query on top of those databases. Making sense, guys? Yeah. So anyone who can tell me what do you understand by RAG, retrieval augmented generation? Anyone? In a layman way. I'm not looking for some fancy word, by the way. In a layman manner, anyone who can explain what do you understand by RAG? No, it's not RAG. I'm just asking you a question. I have to build some context over here. That's the reason. This is not RAG, by the way, but yeah, it's a part of RAG, you can say. Anyone who understands RAG? Conceptually, just conceptually. I'm waiting, guys, for your answer. Searching data from knowledge base. I'm not able to understand. How does it like search like from a knowledge base? Is it RAG? No, I think I have already given the answer. Person with the number 8938. To get the latest data, no, if data is not present in a DB, data can fetch from the source like internet. No, incorrect answer. You find the relevant context based on the semantic search from the vector DB, pass search included with the output. People are not able to give me the correct answer. Oh, okay. RAG is helpful to use own enterprise data which should be exposed to the public. Not all the time, but yeah, quite right. So I'll tell you guys what is RAG, by the way. So what like RAG follows. Let me explain you in a layman way. I feel like after today's class, you will not be able to forget RAG, and we have a chapters on RAG. I'm going to show you practical implementation of RAG. So majorly I have seen that people know these buzzwords because of YouTube videos and all those things. People have created the YouTube videos, but somewhere even they lack in terms of connecting a dots, and because of that, so people are not aware about the actual implementation and the actual concept, what goes behind. Because see, before this class, maybe you guys were not aware about the vector DB, and maybe vector DB was a big deal for all of us. But is it really a big deal? Are we doing something different? I think we all understand the embedding. We are just trying to convert it, store it into some databases. And I think this entire vector database concept is clear. Now I'm going to explain a Chrome, Waviat, Pinecone, Fuzzy, anything, right? You will not find difference at all, right? You will not find a difference at all. Now, RAG, and why I'm talking about RAG, let's try to understand that part. So as of now, let's suppose you will go to Euri, right? You will go to Euri and you will try to chat something. So tell me about Euron. So I'm just asking this question, tell me about Euron. Now, so certainly it seems you might referring to Euron from a Song of Ice and Fire. Yes. So Song of Ice and Fire, book series by George R.R. Martin, perhaps Euron, Greg Joy. Now, when I was asking a question, my intention was different. I'm expecting that it should give me an answer with respect to my Euron. But this is just a pre-trained model, right? Pre-trained model. It's not a live one. It will not be able to answer, right? It will not be able to answer based on the Euron data. Now, step number 2, I'll go ahead and I'll try to select a Flash model. Now, Flash is basically, it can do a real-time search. Now, tell me about Euron. Let's see. It's a search model basically. Euron, perhaps there is another Euron you are interested in. So please let me know which Euron you'd like to know about. So at least it is searching the internet. Tell me about Euron.1 company in edutech. Yeah. Now let's do that search. So basically it is trying to go to Google, and then it is trying to search it, and now it is able to list everything, right? So affordable pricing, comprehensive this, that, and the founder is basically Sudhanshu Kumar. This is Gemini Flash is nothing but it's a real-time search engine. It is trying to do a real-time search. Now, so this GPT Nano Mini, all these models are basically a trained model on a very heavy data set. So it can generate, but yeah, not in a real time, it will not be able to search it. So this kind of a response, you will not be able to get it. One is search, one is like a chat completion, or you can say a sentence generation model that we have. Now, so again, further, if I'm going to ask a question that, okay, so give me a list of courses available in Euron, right? Give me the list of courses which is available in Euron. So tech focus, so it is able to go to Google, and as you can see, it is able to search. We have not done anything, guys. We have not done any integration as of now. It is able to list down all the courses. It is trying to give you all the list of the courses from the Google search. Whatever it is able to find out, it is giving you. Simple, right? Further, you can try to answer. Now, let's suppose there is a guy called as Dev Kumar in my class. I think Dev Kumar is like a typing. There is a guy called as Dr. Syam, Ram, whoever, right? You are. Now, if I'm going to ask that, okay, so tell me something about Dev Kumar. So which courses Dev Kumar is opting for, or maybe like, doctor is going through which and all courses, how much time he is spending or she is spending on a particular course. Now, this is basically a information which obviously even this model will not be able to give, right? Because it's not about a Google search. Now it's all about my database search, a Euron database search, right? Are you able to understand the context which I'm trying to build? Yeah. So now, yeah. So now system is supposed to do an operation even based out of my private data plus whatever model it has learned, because LLM is already having a vast amount of experience. It is having like a knowledge about all the data, right? So what we can do is that, what if while doing a search, like I'm sending a data over here. So how search happens? So let's suppose I'm trying to type a text over here. Now, eventually what will happen? It will try to convert this text into a embeddings. Even now, the result that I'm able to get over here. So it is converting into a embeddings, and then it is trying to generate some information, maybe by using a chat completion model or by using a real-time Google search. And then it is giving me embeddings. Then this interface is trying to convert it into a text. And this is how I'm able to get the result over here, right? This is how I'm able to get the result. Now, meaning of RAG, retrieval augmented generation, is very simple in a layman way, that when you are trying to give a data for a search, right? Let's suppose if I'm trying to ask that what Dev Kumar is like trying to do and generate generate like a complete roadmap for Dev Kumar, only for Dev Kumar, specific to Dev Kumar, based on his data, based on his learning experiences. So what it will do is, it will go to my DB, which is called as knowledge base. Generally, people try to call it as a knowledge base. Knowledge base means technically you are talking about the database or some document or anything, your private document, right? So whenever it will try to send this text, the text which I was sending it and the text which has given me or yielded me this response, along with this text, I will try to add something even from my database with respect to a specific event. For example, a Dev Kumar, right? Now what I'm going to embed. So with this embedding, I'll try to attach my embedding. From where I will be able to get the embedding? Again, vector DB. So basically I can try to keep all my private information into the vector DB. Whenever someone is trying to do a search, any kind of a text, it will try to attach embeddings even from this one. And this whole data will be sent to the LLM. Is it making sense? Technically it's called as RAG. Retrieval augmented generation. Augmented. This is the meaning of this augmented generation. We are trying to retrieve the data from our private data, building the new query string, sending it to the model. And then model will try to, do whatever it does, whatever it is best for. If it is best for search, it will go ahead and do it. If it is best for like a chat completion, it will go ahead and do it. So technically, this is where this RAG comes into a picture. And again, picture will be more clearer and clearer in a practical way when I'll talk about RAG chapter wise. So that is already a part of your like a syllabus, by the way. So guys, are you able to enjoy today's class? Hope all of you are able to enjoy my today's class. Let me remove this string from here. I've just removed it partially. Yeah. Hope all of you are able to understand it. Now in my next class, I'm going to teach you all 4 database together, back to back, back to back, back to back. Yeah. So I'll try to teach you all this 4 because there is nothing to teach in that one. I just have to like create this URL connection string, push the data and then search for the data. Yeah. That's the only thing that I have to do going forward. So now let me rest my ChromaDB. Let me close it. And I'm going to share this code with all of you. D drive code Chroma. What is the folder name, by the way? Okay, vector DB demo. So vector DB demo. Let me like convert it into a zip. Okay. LLM will not learn this private data every time this private data need to be sent. That depends. So that depends actually based on the LLM configuration. So if you have seen the OpenAI interface, I don't know whether you have observed that part or not. So inside a OpenAI interface, they are giving you an option. So make this data public. Means whatever data, if you're trying to do it with their API, whatever data you are sending, your data will be public by default, right? So it depends on the platform as well. And they have already given you switch on, switch off option. So if you're going to switch off it, then in that they are claiming that they're not using it. I don't know. It's their system, right? But yeah, so with Euri, I think we will try to bring those RAG, or you can try to build a RAG. We are not storing those data. Don't worry. So you can try to build a RAG with Euri API as well. And whatever we are storing, whatever we are holding it into the memory, you will be able to see it over here. And even like files. And soon we are even going to give an option to wipe out your entire data, even a memory. For files, we have already given the option that you can try to delete your files so that you will be having all the controls. How to use a Euri API in n8n? So in n8n, says try to create a custom component, basically custom connector component. That option is already available in n8n, and then use it anywhere you want. Simple. Use all the models. Will you teach language with language? Yeah, I'll try to talk. So see, everything we are not supposed to mention inside like a syllabus, or anyhow syllabus is very, very huge and long. But yeah, I'll try to talk about that. That in a practical manner. So, okay, any question for me? For the question, most of the clients in my company are in favor of using OpenLM due to the data being exposed to the outer world. Can you also please teach us quantize model? Quantization is just one single step. So yeah, I can teach you easily, like quantization. Even we do the lot of quantization, not just from like now. I think now people are talking about quantization, right? We have been doing a quantization, and especially with the vision model. I think since like 5 years almost, even more than that. Will you teach a code to create a database like a ChromaDB? That will be very, very huge, doctor. I can teach it. Teaching wise, I don't have any issue, but it's not a part of your syllabus, at least this syllabus. So I'm not going to talk about it. That itself is going to be a big project in itself. But yeah, we are like building internally a lot of such kind of things. Data analysis is coming. You will get to know, Abigail. I mean, not in favor. Yeah, obviously, like companies are not in favor of that. Okay, so I believe I'm done for today. See you again in my next class, which is going to happen on next Saturday. And yeah, so I'll just like follow along with the syllabus. Agenda is clear that what we are going to discuss next and then next. So with that, guys, thank you so much, everyone. See you again in next class. Thank you. All the resources and things are already shared inside your dashboard, so you can just follow along.